What you'll notice about this lesson is that this lesson is very similar to the last lesson we did that were solving one-step equations with addition and subtraction. This is solving one-step equations with multiplication and division. So what you'll notice is the top of your notes page is identical to the top of your notes page from the previous lesson because we're doing essentially the same thing. Solve means to find all the values that a variable can be that will make an equation or inequality true. And again, equations are going to have only one answer, usually only one answer, and inequalities will have many answers. Remember that you can pause these videos at any time. I know I'm going to go quickly through this because it's a review of something we had on a previous notes page. So we are going to be using inverse operations to solve these problems. And inverse operations are operations that undo each other. And you already have these filled in on a previous page, but we want to know that addition undoes subtraction and multiplication undoes division. And while we're solving, we're going to use a balance line. That's just that straight vertical line that goes through the equals sign. And it reminds us of this important concept that I have written in giant letters, capital letters. You can highlight it, you can underline it. You hear it pretty much every day in class. The balance line reminds me that what I do to one side, I must do to the other. So let's start with some examples. And I can almost guarantee you that on this first problem, your instinct is going to say that the answer is 2. And it's not 2, and that's why we're going to show our work. And our work looks like this. We draw that balance line that reminds me what I do to one side, I must do to the other. And this line here actually means division. And the opposite of divide by 9 is times by 9. And I'm going to show this only one time in this video, but I want you to write it down so that you know where this is coming from. I'm going to multiply by 9 as a fraction so that I can show what's actually happening. Over on this other side, I'm just going to write times by 9. Okay, I'm multiplying both sides by 9. But I want to show what's happening on this other side. Well, what I would actually get here is 9 times d, which is 9d, and on the bottom 1 times 9, which is 9. And what is 9 over 9? Well, 9 over 9 is 1. So what do I have? I have 1d, but you know I'm lazy and I'm just going to write the letter d. I'm not going to put the 1 in front of it because you know that there's a 1 there even though I don't write it. So then in order to finish this problem, I need to do 18 times 9, and the way that I've shown it here doesn't really help me, so I'll write it like this. 9 times 8 is 72. 9 times 1 is 9 plus 7 is 16. So the missing number there is actually 162. Remember how at the beginning I thought the answer was 2? Yeah, it's definitely a lot bigger than that. This missing number is 162. On this other problem, I'm going to do the same thing. I am going to put in a balance line. And I notice that what's happening here is multiplication. Hiding in between there is a multiply sign. I don't write it again because I'm lazy. And the opposite of times by 5 is divide by 5. What I do to one side, I do to the other. And I'm going to show, this is part of the work that you're expected to show, that 5 over 5 is 1. This is not a zero pair. So this is very different than the last video where we were crossing things out and writing 0. This is not turning into a 0. This is turning into a 1. 5 divided by 5 is 1. 5/5 is 1. So I now have 1x, which is perfect because that's what I want. I wanted the x by itself. You know I don't write the 1, but it is there. And then I need to do 35 divided by 5, which is 7. I know it might seem like more work than you want to do to show the balance line, to show what you're doing on each side, but I'm asking you to show that because we're training, we're getting ready for algebra, and we want our practice to help us be ready for when we get to the more complicated problems. On this page, you'll notice that there is a definition down here at the bottom. it's on your note page that you need to write in that the multiplicative inverse, which is also known as the reciprocal, are two fractions that when multiplied together equal 1. This was something we talked about at the beginning of the year. You're very good at figuring out what the reciprocal is. So the reciprocal of 3/4 is 4/3. If I multiplied those two things together, I would get 12 over 12, or 1. The reciprocal of 5/7 is 7/5. If I multiplied those things together, I would get 35 over 35, which is 1. And the reciprocal of 1/3 is 3 over 1, or I could just write the whole number 3. And I would get 3 over 3, which is 1. So when we have a problem that shows a fraction like this first one does, I'm going to put in my balance line, and I'm going to multiply by the multiplicative inverse, or the reciprocal. So what is the reciprocal of 1/4? Well, that's 4 over 1. And you guys remember that we can cancel things out that we see on the top and bottom, or we could actually show the work here that 4 times 1 is 4, and 1 times 4 is 4. And you know what we would get? We get 4 over 4. What is 4 over 4? It's the whole number 1. So now I have 1c. And I'm not going to write 1c, I'm just going to write c. And I have to remember, I'm so glad I have my balance line because I almost made a mistake here. I almost just said c is 22. But that balance line reminded me, since I multiplied by 4 over here, I have to multiply by 4 over here. And I can multiply by 4 over 1, since that's what I did on the other side. It would look like this. And I'd get 88 over 1, which is just 88. C equals 88. On this problem, I draw my balance line again, and I look at it and I say, oh yeah, there's that multiplication happening in there. It's not written, but I know it's there. And the opposite of times by -8 is divide by -8. And what I do on one side, I'm going to have to do on the other. And I need to make sure that I'm showing what is happening here. -8 divided by -8 is 1 whole. And 1m, I just write m because I'm too lazy to write that 1. But I'm showing it in my work so that I know I'm doing the problem correctly. Now 45 divided by 8, well, let's see, 8 goes into 45. 8 times 5 is 40. And I must have 5 left over, and it is negative because there is only one negative sign. You could actually go one step further if you remember from your perfect quiz what 5/8 is as a decimal. Here's one more example. I'm going to go ahead and put in my balance line. And I'm going to remind myself that I have to multiply by the reciprocal here to turn this into a 1. When I do that, I get 1m, which then I just have m. So I need to multiply by the reciprocal here. And whatever I do on one side, I'm going to do on the other. I'll go ahead and turn this 40 into a fraction so that I can try and finish this problem. I'd like you to finish this problem on your own by multiplying by the reciprocal on both sides. And on this page, I am trying to point out the fact that 1/6 m is the exact same thing as m over 6. And the reason why, remember, there's that invisible 1 in front of the m that we never write because we're lazy. But it is, in fact, 1/6 and 1/6. This is the same question. They look a little bit different, but they're exactly the same. If I was solving this one on the left, I would multiply by the reciprocal, which is 6 over 1, which is also known as just 6. If I was solving this second one, the one on the right, I would ask myself, what does this mean? This means divide by 6. What's the opposite of divide by 6? Times by 6. on both sides. So no matter which one of these you solve, you're going to get the same answer. These two problems have an identical answer. I'd like you to solve both of them. And our final question here, our final page, oops, went one too far. Our final page in this lesson has to do with questions that have rational numbers. They're solved the same way. I put in my balance line. I see that this is multiplication here, even though it's not shown. And so the opposite of times by negative 2.5 is divide by negative 2.5. So I need to divide both sides by negative 2.5. On this other problem, I put in my balance line, and I see that v divided by negative 2.1, I need to do the opposite of divide by negative 2.1. That means I need to multiply by 2.1. So I would like you to finish these two examples with rational numbers tonight for your homework. Bring them to class with you tomorrow.